Yes, some important compounds of sodium. Important compounds are sodium chloride, sodium hydroxide, sodium bicarbonate, and sodium carbonates are present. These are the four important sodium compounds. Among those all four important sodium compounds, we must have to focus on sodium hydroxide preparation and properties, and sodium carbonate preparation and properties we need to discuss, and sodium chloride and another important sodium bicarbonate internally it will comes. That's not a big problem. Okay, so listen carefully. First we'll discuss about sodium hydroxide. This NaOH. NaOH has another important name in there, caustic soda. Caustic property. Caustic property means concentrated NaOH is reacting, interact with skin. The skin will become fluffy nature. That's why that property is known as caustic property. So due to that nature, sodium hydroxide is also named as caustic soda. What is another name of NaOH, dear students? Caustic soda. So this NaOH we need to prepare. One is directly electrolysis of sodium chloride. Platinum electrode if we are used, then at cathode NaOH will get. Another important method is Kastner-Kellner process. In this Kastner-Kellner process, they change different anodes and cathodes. So the electrolyte is so the Kastner-Kellner process. In this process, the electrolyte is brine solution. What is the meaning of brine solution? Brine solution means not your brain. Brine solution means aqueous sodium chloride, saturated aqueous sodium chloride solution, commonly called as brine solution. Okay, ma? So the electrolyte in this process, Kastner-Kellner process, the electrolyte is brine solution, NaCl. So this electrolysis process, the cathode is mercury cathode they are used, and anode is graphite anode they are used. Okay, students. We know very well in electrolysis process means generally at cathode reduction takes place and anode oxidation takes place. So positive ions goes to cathode and negative ions goes to anode by the ionization of electrolyte. So during this electrolysis process, what are the cathode and anode? We know that. What is the electrolyte? We know that the electrolyte is brine solution or aqueous NaCl. First, the electrolyte will be ionized. That is called ionization of electrolyte. So sodium chloride will be ionized to give Na plus and Cl minus ions. So chloride ions, Cl minus ions are goes to anode. At anode, oxidation takes place by loss of electrons converted into chlorine gas. This chlorine gas will be released at anode. Okay, students. So in this method, chlorine also we can prepare. That chlorine is formed at anode. Aqueous NaCl on electrolysis, chlorine gas is formed at anode. Now the positive ions are goes to cathode, and at positive cathode sodium metal will be deposited. The sodium metal combined with mercury. What is the cathode, dear students? Cathode we are used mercury. Then that mercury combined with sodium metal means the sodium metal will be deposited on mercury. Yes, Nishchal, listen carefully. So this Na plus ions accepting 2 electrons form sodium metal. This sodium metal will be deposited at cathode. The cathode is mercury. Okay, so is converted into Na to Hg. This name is sodium amalgams. For example, mercury is combined with any metals, those named as amalgams. Sodium is there, that's why it is called sodium amalgam. Zinc is present, then it is called zinc amalgam. Okay, the amalgam name is sodium amalgam. The sodium amalgam further hydrolysis, because these reactions are carried out in aqueous medium. Aqueous medium means water is present. So the sodium amalgam reaction with water to form sodium hydroxide and liberates hydrogen gas, again cathode will returns. Okay, so in this method sodium hydroxide we have prepared. The sodium hydroxide is formed at cathode. At cathode sodium hydroxide and hydrogen gases are forming. So in this method the cathode is mercury, anode is graphite. The electrolyte is sodium chloride, NaCl. Okay, students, this method name is Kastner-Kellner process. This method name is a Kastner-Kellner process. Okay, is very very important. Compulsory in 3 marks question they are asking. Now let's see sodium hydroxide properties. We know very well NaOH is a strong base. Properties of NaOH or chemical properties of NaOH. Chemical properties of NaOH. So first one, this NaOH is a strong base. It is a strong base. It reacts with basic oxides. For example, the NaOH reaction with acidic oxide. Sorry, not basic oxide. Acidic oxide. Silicon oxide forms sodium silicate. Na2SiO3. Sodium silicate will forms and liberates water. It is acidic oxide. As well as it is a strong base, it reacts with acids to form salts. NaOH reacts with acids to form salts plus water. Okay, it is one important property. Next, it reacts with metals as well as non-metals. It reacts with non-metals. Reaction with non-metals like boron. For example, sodium hydroxide reaction with boron to form sodium borate. Na3BO3, sodium borate, and releases hydrogen gas. So if you want to balance this equation means 6 moles of NaOH reacts with 3 moles of boron, forms sodium borate. Sodium borate is formed. And similarly, sodium hydroxide reaction with non-metals like phosphorus P4 in aqueous medium. In aqueous medium forms NaH2CO2, sodium hypophosphate, and along with releases phosphine gas pH3. pH3 means phosphine gas. Now you have to balance this equation. It is 3 moles, then 3 moles of NaH2PO2, sodium hypophosphate will form, and 1 phosphorus, and remaining hydrogens atoms combined with phosphine. So this is reaction with the non-metals. Sodium hydroxide reaction with non-metals like boron to form sodium borate, and sodium hydroxide reacts with phosphorus. Phosphorus allotropic form exists in P4. Phosphorus to form sodium hypophosphate and phosphate sodium hypophosphate. Formula is NaH2PO2 and phosphine. pH3 name is phosphine. Phosphine gas. Phosphine gas it will be. This is reaction with the non-metals. Let's see the reaction with metals. Next important property is reaction with metals. So this sodium hydroxide reaction with aluminum forms sodium aluminate. NaAlO2, sodium aluminate will forms. And releases H2 gas. You have to take 2 moles. Then we need to take 2 moles of aluminum. NaAlO2. Now sodium hydroxide and reacts Na to AlO2. Na to AlO2. Sodium aluminate will forms. Next, when reaction with zinc, sodium hydroxide reaction with zinc metal to form sodium zincate. Na to ZnO2, sodium zincate, and releases hydrogen gas. Okay, students, listen carefully. Reaction with metals. Sodium hydroxide, Saujanya, listen ma. Sodium hydroxide, NaOH reaction with aluminum metal forms sodium aluminate, NaAlO2, NaAlO2, and hydrogen gas will release. As well as zinc metal also forms sodium zincate, Na2ZnO2 and H2 gas. Okay, so whenever sodium hydroxide reaction with metals like aluminum and zinc forms corresponding aluminates or zincate and releases hydrogen gas. Okay, students, let's see another important chemical property is the sodium hydroxide reaction with excess of means fourth one, excess of NaOH reaction with ZnOH twice, zinc hydroxide and aluminum hydroxide, AlOH thrice. Aluminum hydroxide forms soluble complex. Soluble complexes. Let's see what are the formula of soluble complexes means. For example, this NaOH reaction with AlOH thrice, aluminum hydroxide forms Na3AlOH 6 times. Na3AlOH 6 times means 3 moles of sodium hydroxide. If it is excess, then this is this complex. This complex is also we have represented like AlOH 6 times 3 minus. It is a soluble complex. It is completely soluble in water. Aqueous NaOH. This aqueous NaOH, excess of aqueous NaOH reacts with aluminum hydroxide or zinc hydroxide forms soluble complex. The same way, it is reaction with zinc hydroxide forms Na2ZnOH 4 times. These also soluble complex. So these are the main important chemical properties of NaOH. NaOH is a strong base. It reaction with acidic oxides or acids to form corresponding salts. NaOH, sodium hydroxide reacts with metals as well as sodium hydroxide reaction with non-metals, and sodium hydroxide reaction with zinc hydroxide or aluminum hydroxide forms corresponding soluble complexes. Okay, students, these are the main important chemical properties of sodium hydroxide. Let's see, already today I shared one important uses of sodium hydroxide. Sodium hydroxide uses already I shared. What are the main important uses of sodium hydroxide? Sodium hydroxide uses. If you are aware that this sodium hydroxide is a strong base, it is a good laboratory reagent. Sodium hydroxide is a strong base and good laboratory reagent. It is mainly used for the making of soaps industries and textile industries and paper industries. Mainly we are using sodium hydroxide, and this sodium hydroxide also we are used in refining of petroleum, means in petroleum industries for refining of petroleum process, sodium hydroxide we are using. So these are the main important uses of NaOH. Okay students, and for bleaching of textiles, in textile industries also NaOH we are using. Okay, let's see next another important compounds of sodium is sodium carbonate. Sodium carbonate, Na2CO3. Sodium carbonate preparation, Na2CO3 preparation by Solvent process. Solvent process. See, in this solvent process, how we are preparing Na2CO3, sodium carbonate, how we are preparing. Let's listen carefully, dear students. In this solvent process, just you have to take one big beaker or container. In this container, just first you have to take brine solution, NaCl. NaCl solution. This NaCl solution we are passing ammonia, aqueous, NaCl. We are passing ammonia and carbon dioxide. So ammonia gas and carbon dioxide are passing through the aqueous saturated sodium chloride. They forms first ammonium bicarbonate. That ammonium bicarbonate reacts with NaCl, forms sodium bicarbonate. The sodium bicarbonate is a precipitate and it is insoluble. That's why just we have to filter it off. Then that that precipitate just upon heating, then we'll get sodium carbonate. Okay, students. Let's see first ammonia and carbon dioxide, and in aqueous NaCl solution what is present. First step, they forms NH4HCO3, ammonium bicarbonate forms. Okay, ammonium bicarbonate is formed. This ammonium bicarbonate, NH4HCO3, this ammonium bicarbonate reacts with sodium chloride. NaCl forms NaHCO3, sodium bicarbonate. So you want only sodium bicarbonate, means just you have to stop the reaction at this step only. And byproduct is ammonium chloride will forms NH4Cl. Okay, this sodium bicarbonate is precipitate, PBT, sodium bicarbonate precipitate will forms. It is insoluble in aqueous medium. Or insoluble in saturated brine solution. This precipitate just you have to filter it off. Then the precipitate is again you have to heat that precipitate strongly. Then we'll get sodium carbonate. Next, step 2. This NaHCO3 is on heating. Then we'll get Na2CO3. Na2CO3, sodium carbonate and H2O and CO. Okay, students. Now finally we are getting sodium carbonate is formed. This process is known as solvent process. Okay, anybody have doubt? How to write the statements? Listen carefully. The statement you want to write means ammonia gas and carbon dioxide gas are passed through the saturated brine solution. That point first we have to write. Ammonia and carbon dioxide gases are passed through the saturated brine solution. Then first ammonia and carbon dioxide and water reacts to form ammonium bicarbonate. This ammonium bicarbonate further reaction with NaCl to form sodium bicarbonate precipitate. Okay, students. This sodium bicarbonate precipitate is filtered off. Then the precipitate filtered off. Then we'll get NaHCO3, sodium bicarbonate solid. That sodium bicarbonate solid upon heating, then we'll get sodium carbonate. Sodium bicarbonate is on strong heating, then we'll get sodium carbonate. Sodium carbonate and water and carbon dioxide gas will come. Sodium carbonate is formed. Okay, this method is known as Solvent process. This method is known as a Solvent process. Okay. Yes. Now we need to discuss about Na2CO3 sodium carbonate properties. We need to discuss. Properties of Na2CO3. What is the importance of Na2CO3? Let's listen. Na2CO3. Na2CO3. Na2CO3 10H2O. Decahydrated sodium carbonate is known as washing soda. Okay, what is the chemical formula of washing soda? Washing soda chemical formula is decahydrated, means Na2CO3 10H2O or decahydrated sodium carbonate is known as a washing soda. Okay, yes. Now listen carefully. This Na2CO3 10H2O washing soda is on heating below 373 Kelvin's temperature. Below 373 Kelvin's temperature, then the 9 water molecule comes outside. Forms Na2CO3H2O. Monohydrated sodium carbonate will form. If it is on heating above 373 Kelvin's temperature, heating above 373 Kelvin's temperature, those all water molecule will come outside. Then forms Na2CO3, sodium carbonate, anhydrous Na2CO3. This anhydrous Na2CO3 is known as soda gas. Soda gas. Soda gas means anhydrous sodium carbonate. Anhydrous sodium carbonate is known as a soda gas. Okay, it is very, very important. These formulas are very, very important. Washing soda chemical formula or molecular formula is Na2CO3 10H2O. Soda gas means Na2CO3, means all water molecules will come outside. Then that is known as anhydrous sodium carbonate. Anhydrous sodium carbonate is also called as soda ash. Okay, students, let's listen. Another important point related to sodium carbonate is the sodium carbonate is a salt of Na2CO3. Na2CO3. Sodium carbonate, just you have to keep it in water, then to form NaOH, sodium hydroxide will forms. Means you have to take 2 moles, then and forms H2CO3, carbonic acid. This is as listen carefully. NaOH is a strong base and it is a weak acid. So Na2CO3 is a strong base and weak acid salt. Weak acid salt means it has basic nature. It is has basic nature. Na2CO3 in aqueous medium, it producing sodium hydroxide, means basic strength is more when compared to acid. It is a weak acid. That's why the corresponding sodium carbonate has basic nature only. The salt has a basic nature only. Okay, students, this Na2CO3, whenever this Na2CO3 sodium carbonate is treated with dilute acids or acids, mineral acids like HCl and H2S4 forms corresponding salts, like and releases carbon dioxide gas. Whenever it releases HCl to forms 2 moles of NaCl and carbon dioxide gas and H2O. Okay, students. Like in the same HCl place, we have to take H2S24, then also forms Na2SO4 and H2O and CO2 gas. So that's why the sodium carbonate is reaction with acids, mineral acids. That's why sodium carbonate has basic nature, and it releases carbon dioxide This is important properties of sodium carbonate. Okay, students, and sodium bicarbonate and NaCl are also important. Just but preparations and all not required. So for first year group elements, main important compounds of sodium is sodium hydroxide and sodium carbonate. Preparations and properties all we are discussing. Let's see now. We'll discuss about the important compounds of calcium. Important compounds of calcium. See here, calcium important compounds are calcium oxide, calcium carbonate, calcium hydroxide and calcium sulfate, dehydrated calcium sulfate and hemihydrated calcium sulfate. Those all are very important compounds of calcium. So first we'll discuss about that important compounds, calcium oxide, CaO. This calcium oxide is also known as quicklime. Calcium oxide is also known as a quicklime. Now we'll discuss about the preparation methods of calcium oxide. Preparation methods. What are the important preparation methods of calcium oxide is present? For example, calcium carbonate CaCO3 is on strong heating in a open vessel, not in closed vessel. Closed vessel means again that backward reaction will take place. So in a open vessel, then forms calcium oxide solid plus carbon dioxide. It will come. Okay, students, this is the first method. Next, second method is calcium carbonate. Second one is this main important preparation of calcium oxide is calcium carbonate on heating, then we'll get calcium oxide. This is also named as quicklime. Okay, it is also named as a quicklime. Let's see the properties of calcium oxide. Properties. Properties, this calcium oxide is a basic oxide. Calcium oxide is a basic oxide. Okay, students, whenever it reaction with basic oxide means it reaction with acidic oxides to form salts. Reaction with SiO2. SiO2 is acidic oxide. So calcium oxide reaction with SiO2 forms calcium silicate. CaSiO3. Calcium silicate. Its name is calcium silicate. Next, calcium oxide reaction with ammonium chloride. This calcium oxide reaction with ammonium chloride, NH4Cl, forms. You have to take 2 moles, forms calcium chloride, CaCl2 plus 2 moles of ammonia and water molecule. Ammonia and water molecule. Okay, students. So calcium oxide is known as quicklime. that calcium oxide can be prepared by the heating of calcium carbonate in a open vessel. And the properties: calcium oxide has basic nature or basic oxide. When it reacts with acidic oxide like silicon dioxide SiO2 forms calcium silicate CaSiO3. When it reacts with ammonium chloride to forms calcium chloride and ammonia and water. Okay, students, this is about important preparation method and properties of calcium oxide. Calcium oxide is named as quicklime. Okay, let's see second important compound of calcium is calcium hydroxide. The second one is calcium hydroxide. CaOH twice. This calcium hydroxide is known as slacked lime. Slacked lime. Calcium hydroxide is known as a slacked lime. It can be prepared. Calcium oxide treated with water forms CaOH twice. Calcium hydroxide will forms. And another important method is calcium chloride reaction with base like sodium hydroxide forms calcium hydroxide. And these are the important preparation methods of calcium hydroxide. This is also known as slacked lime. Now, this calcium hydroxide, what is the importance of calcium hydroxide means? This calcium hydroxide important chemical properties, this reaction with carbon dioxide. This calcium hydroxide reaction with carbon dioxide forms calcium carbonate CaCO3 and H2O. If it is limited amount, then it is forms calcium carbonate precipitate, milky white precipitate. Milky white precipitate. For example, if it is excess of if you are taking, then it is excess forms CaHCO3 twice. CaHCO3 calcium bicarbonate will forms. It is excess forms calcium bicarbonate. It is a soluble compound in water. Okay, students. So calcium hydroxide treated with limited amount of carbon dioxide forms calcium carbonate precipitate. Then it is called milky white PPT. Instead of taking limited amount, excess you are taking like that. Means if you observe that this equation we can write like this also. CaOH twice plus 2CO2 means 2CO2 then forms CaH